Okay, hello everyone. Today we're going to be looking at valid palindrome. So you're given a string and you're asked to determine if that string is a palindrome, considering only alphanumeric characters and ignoring case. So here, since we ignore case, for simplicity's sake, let's consider everything as if it's lowercase, the lowercase version of this. And you only consider alphanumerical characters, which means you wouldn't consider this colon, you wouldn't consider these commas. So here you have A, then M-A-N, M-A-N, A, etc. And you also don't, you wouldn't consider spaces in here. And you notice that this is a palindrome. Here you notice this is not a palindrome because of the A. If you remove the A, it would be, but since you look, if you were to, a good way to think about this is actually with 2 pointers. So here we have race a car. So what we can do is here, if I just write it down, you have R-A-C-E. I'm just going to ignore the spaces since, well, and we're going to end up removing them anyway. So you have race a car. And if you could consider 2 pointers, you have the left pointer and you have your right pointer. And what you can do is you can notice that R and R are the same, so you can move each one inwards. A and A is the same. Move them inwards. Is C and C the same? It is. And then until they meet, when they meet, you would stop. But you would notice that here they haven't met yet, but they have. And when I say they haven't met, I mean L is still before R. It met. If they had already met, then it would be like L is past R, but L is before R. So they haven't met yet, the 2 pointers closing in on each other. And they've noticed a discrepancy. E and A are different. So because E and A are different, what we can say is that this is not a palindrome. But if we look instead, if we want to look at a man, a plan, a canal, Panama, we can set up our 2 pointers. We have L and R, and we notice that here A and A are the same, so M and M are the same, A and A are the same, N and N are the same. Here, I'm just gonna, and we can notice A and A are the same, P and P are the same, L and L are the same, A and A are the same, N and N are the same, A and A are the same, and then here, we still need to check this one, but this is kind of trivial, C and C will always be the same. Then we move L over, we move right over, and then we realize the while condition, L is no longer less than R, so then we stop, and we return true. If at any case we had found, with the race a car example, if we had found any matching stuff, we would non-matching stuff, then we would have returned false. In here, as soon as we found the E and A that weren't matching, we return false. So hopefully that helps give some intuition on how you would do it. But here I'll just code it up to make it solid. So we set up 2 pointers. We have our left pointer and we have our right pointer. Our left pointer starts at the start. Our right pointer started at the end. So that's going to be the length of S minus 1. And we just keep on going while L is less than R until they intersect, the 2 pointers. And we just want to keep on moving them along. So one way we could do this, and here I'll just set it up at the bottom. We know that we're always going to be increasing L by 1 and decreasing R by 1. Why is this? Well, L always moves to the right. L always moves inwards. The right pointer always moves inward as well, but it always moves to the left. So it's always decreasing, while the left one is always increasing, if you think in terms of indices. So, and here we need to actually need to make sure that they're the same thing. How do we make sure they're the same thing? Well, we have our indices. So, and we have our string S. So we can check S sub L and we can check S sub R and we can compare them. We can say, are these equal? Or for this case, we wanted to say if they're not equal, then you want to return false. But something we also need to know is we need to make sure the entire thing is lowercase and alphanumeric. So over here, what we can do is we can say dot lower to make sure we're looking at the lowercase. You could also do dot uppercase for both of them. It has the same effect. But to make sure that we aren't looking at any alphanumeric characters, what we can do is we can literally just like set a while loop to keep on going until you have something that's not an alphanumeric character. So not S sub L dot alnum and no. Yeah, then we can just keep on increasing one and we can decrease R with like the same logic. While L is greater than R and S sub R, the string of index R is not alphanumeric, then you want to keep on increasing. So we're just like going past the alphanumeric, non-alphanumeric characters. So we know that whatever S sub L is here, we know it has to be alphanumeric. So yeah. And if we pass it, as we said, like with this example, as soon as they pass each other, the while loop will break, and that means we want to return true. Here, we actually pass the pointers. The 2 pointers pass each other. We return true in that case, because it is a palindrome. Hopefully this works. Oh, string has no attribute. Oh, I think it might be like is alnum, maybe. The algorithmic thinking is the important part of this, not the syntax. So yeah, this seems to work. Probably will work if... Oh yeah, so this works. It's not the fastest. So something else we could do, it's always nice to think of like multiple approaches. This is actually kind of like a hack, but I like it. What we could do is we could make an array. We could say like my string equals, and then we can do a list comprehension if you remember that like from your 61A days, and we can say for CH, for every character in the string S, and only if that character is alphanumeric, this time I won't forget the is, then what we can do is we can just return if my string, or like clean string might be a better variable name, like cleaned, because we're looking at like it cleaned from all those non-alphanumeric characters like spaces, colons, commas, and we want to see is that equal to the reverse of this. How do we see the reverse of something? In Python, you can do this really easy. You don't have to like do a for loop through like to n over 2, like swapping the first and last. You can just do this, and this should probably work as well if I didn't make another typo. Oh, I did. Lower should be there. How did it compile? Okay, yeah, hopefully this works and I stop embarrassing myself with typos. But yeah, and something you'll notice is that this takes more memory despite being a tad bit faster, and the reason why is because this is actually O(n) space. It's a linear with respect to your input size, so if your string S had like 1,000,000 characters, you would have to go through every single one of those 1,000,000 characters here, no matter what, and then you have to like and you have to create a list for that, and then you have to create a new list for this. With the 2-pointer approach, if I can get that back. Yeah, with the 2-pointer approach, we weren't storing anything. It was constant with respect to space. We have these 2 pointers, but that's like that's constant space. We weren't doing linear space, and it didn't, the amount of space we take didn't really matter with respect to our input. We're only just having these 2 pointers, while otherwise with the other approach, while it is faster, you do have to store the entire array, and you actually have to store the entire reversed array. So that's technically, the other one was big O of 2n, but as we know, big O of 2n is in big O of n. So that's big O of n space, while this is big O of 1 space. So I guess you could make like a comment here, O1 space, and this goes through the entire array once, so no matter what, I think it's going to be hard to get through big O of n time. So this is a nice solution. I like it. But yeah, it does have a slightly bigger constant in here, but they're both valid approaches. So catch you in the next one.